Hello, hello. So this question is asking us, or telling us that the function g of x is defined below, and we see that function here, g of x. As x approaches positive infinity, g of x will approach something. And so our goal here is to figure out, well, what's the end behavior of the function g of x? Remember, whenever we're doing end behavior, we only care about the leading term, the term with the highest degree in each polynomial. And so on this top one, I see that I don't care about the 5x and I don't care about the negative 3 because there's a negative 10x squared. So we can say that g of x as x approaches infinity, I'm going to write that here, as x approaches infinity, the numerator is pretty much just going to be determined by negative 10x squared. And the denominator is going to be, well, we don't care about the 2x squared, we don't care about the 8 because there's this 15x cubed term. So as x approaches infinity, g of x will approximately equal this, negative 10x squared over 15x cubed. Now the next step that we need to take is to simplify this. I see that, negative 10 and 15, both of them can be divided by 5, and so that means I'm going to be left with a negative 2 on the top and a 3 on the bottom. And then x squared and x cubed. Well, which one's bigger? Well, I know that x cubed is bigger, so I'm going to do 3 minus 2. It's going to give me 1, and that x is going to stay in the denominator because that's where the bigger exponent was. And so that means I see that as x goes to infinity, the function's pretty much going to look like the function negative 2 over 3x. Now, this is where we plug in infinity. We think about what's going to happen if infinity is there. Now, negative 2 over 3 times infinity. Here, we're not actually plugging in infinity. I'm going to put a little star here. Not real, what we're doing. We're just thinking about what would happen if we went to infinity. Well, we're putting a really, really big number in the denominator. We know that, as the denominator gets bigger, so we can look at like 1/2, right? If we look at another fraction, 1 over 4, well, the denominator's bigger, but 1/4 is smaller, right? And then 1/8, that's even smaller. 1/16, that's even smaller. And so here, if we have a really, 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 really big denominator, we're pretty much going to end up with 0. Because we're going to have such a piece so small, such a fraction so small, that it's pretty much 0. And so that means that as x approaches infinity, g of x, in this case, for this rational function, will approach 0.